Thank you, Patty.
All right.
That's wonderful.
All right. Thank you, everybody, for attending. Welcome. My name is Kade Bolger. I'm a full-time woodturner, production woodturner, artistic woodturner, teacher, and demonstrator. Today, the demonstration will be all about turning a wig stand for your local cancer support center. Just got to catch my breath here, running up and down the stairs.
Sorry, Kate, I muted you.
No problem.
Okay.
So just a little bit of housekeeping first off. During the meeting, everybody will be muted. If there are questions, feel free to unmute yourself at any time and ask those questions. I also do have a moderator. So if you can also type your questions into the chat bar. You can type those questions into the chat bar, and whenever I have a pause, I'll ask, are there any questions? And either my moderator can ask those questions for you, or you can unmute yourself, ask those questions, and then mute yourself again, just so there's no distractions for anyone else. I'll start off in this demonstration. I'll start off talking about the project we're going to do, a little bit of safety throughout, as well as all the tools and techniques I will use in this project. So today we're going to turn a wig stand for your local cancer support center. This is the project here. This one is made out of ash. It's a really nice project for both spindle turning and faceplate turning. Great practice for your tool control techniques, and it is a great cause to help someone in need. Here is another one I turned yesterday out of ash. Now, and here is one out of maple. This one I textured and I burned with a wood burner. So I used stippling here to create a tiger stripe. I did shading on the side for a leopard print, and then at the bottom I did almost like a zebra or a tiger stripe following the wood grain of the grain of the wood, okay? So you can use any wood, any different types of woods you would like. Feel free to use any woods you have. You can laminate wood together. You can buy lumber, you can use hardwoods and softwoods. So if you're going to use softwoods, the only thing you need to keep in mind is that they can dent easily with fingernails, jewelry getting thrown in the dish, or if it gets dropped. But also in using softwoods, if you're going to stain the piece, you're going to want to use a sanding sealer of some sort, so when you add stain to the piece, it doesn't become muddy, absorbing the finish at different rates and different depths. When I make wig stands, I predominantly use hardwoods, but you can use softwoods or building materials as well. Okay. If you use softwoods like pine, if you buy a 12-foot board, 8 inches wide, 2 inches thick, that will cost you roughly $31.65. And out of that one board, you will get 13 wig stands. So each wig stand will cost you about $2.45. Now, if we do that with ash, that same board will cost you $77.60. Again, you will get 13 wig stands, and each wig stand will cost roughly $5.97. If we do it in cherry, which I'm going to use today, I'm going to use cherry for the project today. If you use cherry, that same 12-foot board, 8-inch wide, 2-inch thick, will cost you about $92. And again, you will get 13 wig stands, and each wig stand will be roughly $7.07. So whenever I turn, let me tell you first a little bit about the wig stands and the cause of the wig stands. So I have been doing this charity and making wig stands for my local club. I've been running the wig stand mission for the Durham Woodworking Club for about 8 years or so. And through that club, we have turned 545 wig stands that we have donated to cancer support centers around Canada, around Northern Ontario, wherever there is a need, we donate those wig stands. I have also started doing demonstrations for many clubs, and I have many clubs on board around the world now working towards the cause and supporting the cause as well, which is very fulfilling and uplifting to me. I'm glad to help, and I'm glad to share such a nice cause that is so very near and dear to me and my heart. So since COVID hit, I started a small charity called Wig Stands for Cancer Support. Now, this is a monetary charity. I had interest from around the world from people who would like to support the cause. They couldn't necessarily get wig stands or wig kits from me, but they would like to support the cause. So they could donate monetarily to my wig stand PayPal charity. And within that charity, all proceeds go towards wood for the cause. No one ever pays for a wig stand, okay? I donate my bandsaw blades to mill up this wood. I have already donated 3 12-foot boards of my own, and I have had quite a few generous donations from around the world that has also helped the cause and for me to get timber to support the local surrounding clubs to make wig stands for their local cancer support center. So my PayPal charity will be put in the link. It is PayPal.me/wig stands, and all proceeds go towards the lumber to support the cause. Okay? Also, feel free to adopt this cause with your own club. There's always a need around the world. Okay? So enough about that and enough about me. I talked about preparing and preparing your wood if I were to buy lumber. I'll go more into depth about preparing your wood just before we mount the wood on the lathe and get into the turning, make a mess. First, I would like to do a small little safety scenario. So whenever I'm turning, I always wear safety glasses and I always wear a full face shield. The Honeywell face shield is very good impact resistance. Even the smallest things, like maybe a bottle stopper, if that came off the lathe, it could potentially be traveling at a high rate of speed and it could do some damage. Protect your eyes, protect your face, okay? You can also see I'm not wearing any rings, bracelets, watches, chains. Jewelry can catch corners of the wood and pull you into the lathe, potentially doing harm. Long sleeves, I prefer short sleeves because long sleeves, again, can catch the wood and pull you into the lathe. If you wear long sleeves, I recommend cufflinks or roll them up past your shoulder. Lastly, I always wear earplugs because wood turners always often go deaf, especially in their left ear, if not both, from the sound of the motor, but mostly the chatter of the tool cutting the wood. So protect your hearing. A pair of custom earplugs is far less expensive than one hearing aid, so protect your hearing. Closed-toe shoes, I don't recommend turning in sandals, even if this blank, which weighs maybe a pound, if that fell off my bedway at 3.5 feet, and that hit my toe, especially on one of those corners, you have very small bones in your feet, and this will break bones. It can do some damage as well as cut you or do some damage with the corners. So there is a bit of a safety disclaimer, and throughout the demonstration, I will also be telling you a little bit of a safety disclaimer, what to watch out for, where to keep your hands, and what not to do, how to present the tool safely, efficiently, and why you wouldn't present that tool in that fashion as well. Okay? Now I've gone through the project, I've gone through the charity, and I've gone through the material. Now we'll talk a bit about the tools I'm going to use today. So the tools I'm going to use today, when we turn the top and the bottom of our wig stand, it is basically faceplate turning. So when I turn those pieces, I use a bowl gouge. Just gonna switch my camera here. So these are the two bowl gouges I will be using today. They are Robert Sorbet bowl gouges, and they have a grind of 55 degrees, swept back to 120 degrees. And this one is 60 degree, swept back to 120 degree. These are both Irish grind, or also known as the Ellsworth grind, okay? So those are the two tools I will be using for doing the dome and the base of our wig stand, okay? The other tools I will be using today will be your standard diamond parting tool, a bevel of 25 to 45 degree bevel angle on either side, depending on the preference of the wood turner. For the spindle turning, I will be using predominantly my 1/2 inch skew, which is a slight radius skew, cutting angle of 70 degrees, bevel angle of 25 degrees on either side. I usually hone my skew, but for this demonstration, I finally sharpened it again because the hone started to creep up. I got rid of the hollow grind, so eventually I go back and I grind it probably every 6 months, and I hone in between. Significantly makes your tools last for a long time. So believe it or not, this tool is over 11 years old, and I might have only lost maybe 1 inch while honing and grinding every 6 months. Okay? People might say, well, to go to the grinder, it only takes seconds to sharpen your tool. But to stand in front of your lathe and to hone that tool, it also only takes seconds, and you remove maybe a micron of steel rather than a few millimeters. The other tool I will be using is a spindle detail gouge. This is sharpened to 30 degrees. Okay. Now those are the tools I will be using today. And now, any questions about the tools, the safety, the project? Now I'll get into preparing and mounting your material. So when we make wig stands, when I prepare my material, like I said before, if I go to the lumber yard and I get a 12-foot, I hope this stops flickering on me. One sec here. Just double check my device. Oh, shoot. Sorry, no problem. I just had to shut it and reboot it. Oh, but it didn't help much. There we go. Okay. So now we'll talk about preparing and mounting your materials. So today I will be using cherry. Now, when you prepare your wig stand kits, your base can be anywhere between 6-inch square up to 5-inch square, between 5 and 6 inches square. Now, your base can be 2 inches thick, or it can be 1.5 inches thick. It all depends on preference and how many wig stands you can get out of that piece of lumber. So if I cut this to 5 by 5, I would make the dome probably 4-inch. You want the base to accent the dome. You want the base to be a little bigger, a little heavier, so if the table gets jostled, it's not going to fall off the table, okay? So sometimes when I prepare these kits, I will make the base and the top 5 by 5. That is only so I get the maximum amount of wig stands out of the selected piece of lumber I bought. When I turn that, I would turn it to 5 inches and 4 inches so they complement one another. With the piece of cherry, I had a bigger piece, 12 feet long, 8 inches wide, 2 inches thick, so I got 13 wig stands out of it with a base of a 6 by 6 by 2 and a dome of 5 by 5 by 2. Now the top of the spindle is 2-inch square and 11 inches long. It can be longer, it can be shorter, but the overall height of your wig stand, you want it to be anywhere between 13 inches and 15 inches tall, okay? You can make it taller, but if it is for a wig stand cancer support center, they have a room in the back where they hold their wig stands. And a lot of times, the distance between those shelves where they display their wig stands so their patients can come and pick their wig stand that they desire is about 16 inches tall. So if you make them taller than 16 inches, they won't necessarily fit within the shelving rack that they allow the patients to choose them from. Okay, they can be shorter, they can be longer, but keep in mind they're usually displayed on a 16-inch height shelf, okay? Now you want the dome of the wig stand to be 5 inches or less. It can be anywhere from 3.5 inches diameter up to 5-inch diameter. You don't want the diameter larger than 5 inches because when the wig stand gets wet and it dries and it sits over top of this dome, if it is bigger than 5 inches, it can actually stretch the crown of that wig stand and it won't fit the patient properly, okay? So when you make your dome, you want to make it a good curved dome shape that follows the curve of a human crown. You don't want it to be square or too oval-like because, again, it can stretch and disfigure the wig as it's wet and drying on top of your wig stand, okay? So I've prepped this material here to 6 by 6, 5 by 5, 11-inch long, 2 by 2 square. You can make it thinner, thicker, whatever you like, but those are the rough dimensions of your wig stand. This camera. Okay. So when I prepare these materials, first thing I do, now you can take a ruler and you can go corner to corner, corner to corner to find your center. I like using a center finder because it's very quick. And whenever I find the center, I always find the center on all 4 sides, just in case that piece is not perfectly square. I want to find my dead center so it's as balanced as possible on the lathe when I mount it. And in doing so, when it's as balanced as possible, you can start at a faster speed, you can turn safely at a faster speed, and your lathe isn't rocking and rattling across the floor as you dance with it to turn that project. It's not safe to have your lathe dancing across the floor. So you want your piece always as balanced as possible. Now, when I find my centers on both sides. Okay? Just for a reference for my spur drive and my live center on my tailstock. I do that on both the top and the bottom piece. Now, when we turn these wig stands, you can be as creative as you like, and we will try a few different techniques to make these wig stands curvy and shaped and figured. So I find my centers on all four sides. I split the difference, and I know that is my perfect dead center. Okay, perfect dead center. When I do the spindle, I do the exact same thing. And I would do that on all four sides. Now, I've already done it a few times. We don't need to see me do that again. And I will have my centers on all four sides of the piece that I'm going to use. Okay? If this keeps flashing, I'm just going to do another one afterwards that I'll send out to everybody where it's not flashing. Okay?
It's not too bad, Kate. Just keep carrying on. I think maybe it's the weather that we're bringing in, and Rogers has had some problems this week.
Yeah, that's true. Alrighty. So now we have our material prepped. We cut it out of our 12-foot log. We got 13 blanks out of our log. We have it prepped to the dimensions. We found our centers on all four sides. Now there's different ways you can turn this. I do them two ways, okay? First thing I do once I have found my centers is I take those pieces to my drill press, or if you're in the UK, it's a pillar drill, and I drill a hole in the dead center of my converging lines, okay? So with this, I drilled a 1-inch hole because my spur drive is 7/8 of an inch. I drilled that hole 3/4 of an inch depth into the blank. Now, if I drill a 1-inch hole, I can use my spur drive and I can bring that right up in there, and I bring up my live center tailstock for support while I turn that piece, okay? If you're a little nervous about turning only with the spur drive and your live center, that's okay. You can use spigot jaws. But this is still a very safe way to turn it because this spur drive is embedded in this hole. It's biting into that timber so it can safely drive the wood as well as keep it on the lathe. And with the tailstock pressure, it's going to keep the pressure on that live spur, keep the spur within that hole, and it's perfectly safe to turn that between centers. Now you can also use a spigot jaws. Spigot jaws. Now if I were to use these, and I have used these before, these are one-way spigot jaws, which are in my one-way Talon chuck. And the diameter of this is 1 1/8 inches. So if I'm going to use this and I'm going to stick that within that hole, I need to drill that hole 1 1/8 inches. Now it's going to be a tight fit if I use this. You can also drill 1.25 inches, and that will fit perfectly. Expand this within that mortise and it will be a very secure hold, okay? Again, we would bring up our tailstock for support, okay? This is a very beneficial way to do this because I can remove my tailstock and I can now create my recessed tenon here how I see fit. And I think I might run into that problem because I'm using the spur drive, but you can get around it doing it this way as well. Okay. So those are the two ways I would start turning it on the lathe, either with my spur drive or my spigot jaws. I'm going to use my spigot jaws. It's a safer option. I just need to drill that quickly. Sorry about that. So here I am drilling. I'm just setting up my 1 1/8 inch bit in my drill press here. And I'm going to drill those holes in these blanks just because it's a safer, easier option than doing it between centers. I forgot about the aspect of putting your recess tenon on the base of your bowl. But that's okay. We modify on the fly. All right. I didn't think about that in the beginning. Sometimes if you just do it between the spur drives, it's a little tricky to make your recess to hold your tenon while having your tailstock there. It's totally possible, but you might have a high side or a pin there, or you have to turn it to a small pin so you can remove it afterwards. But by doing it with the spigot jaws, like I'm going to show you, it's a lot easier. A lot less fiddling and fussing around. Okay, so I'll throw my spigot jaws on here. I drilled this hole to 1 1/8 inch, which is the exact diameter of this. It will be a tight fit, but that's no problem for our live center because our live center will push that into place, okay? So the first thing I turn is usually the base. And when I turn the base, I look at the grain orientation to see if I want any specific design in the top of my bowl, or the bottom's pretty plain Jane. It's just going to have a recessed mortise so I can hold it, so I can turn the inside. Okay. This is pretty straight grain. It's going on a diagonal, so I'm not going to really have any spectacular grain patterning in it, but we can make it beautiful by shaping it, curving it, beading it, and whatnot. Okay. Here we go. That fits on there just like that. I drilled this hole 3/4 inch deep. I bring up my live center, lock my tailstock in place. Now that is embedded within my jaws. It's a tight fit, so I probably don't really need to open this much, but if you feel like you can. Okay. Now, when we start turning this, let's talk quickly just about grain orientation. Now, this is basically a bowl where the grain is running crisscross. Now, the base is like a bowl. So this will be the bottom of our bowl. You can shape it, you can curve it, you can come straight across, you can curve it inwards. I mean, the design elements of this are endless, and you can be as creative as you like. But when we turn a faceplate piece like this, the grain is running in this direction. So we always want to cut downhill when we cut in turning. It's one of the laws of turning. You always cut downhill. It will minimize your vibration, your resistance, and severely minimize any catch. Okay? So if I were to go straight into this piece here, I would be cutting downhill, uphill, downhill, and uphill. Move this back a bit here. There. Yep. So on this cut, I would be cutting downhill into the end grain, uphill, downhill, uphill. So you would never come onto this piece straight on, because you will get one nice cut and then you hit end grain. Oh, it's very porous. It will grab that wing, catch that tool like no other. It will be one hell of a violent catch, and it will let you know what not to do. Also, in going uphill, you might break these fibers out, and then we have a sliver flying through the air. And I mean, if you have a sliver flying through the air, 9 times out of 10, it's always going to land right here. Just by chance, luck of the draw, it's always going to hit you. So where we can, we always want to cut downhill. So if I cut here, I would be cutting downhill but uphill. But if I approach this material coming in on the side grain and cutting across those end grain fibers, now I am cutting downhill, because the fiber underneath, as I cut across that face grain, supports the cut I am making underneath it. So it's a nice cut, a nice finish, far less sanding. If I were to go the other way, it separates cuts. Okay, separates cuts. And that's what gives you all that tear out that everybody hates sanding. It takes forever to sand tear out on end grain. Okay, so where you can, you always want a nice finish, and you get a nice finish by cutting downhill. Okay, and that will be the same. I'll reiterate that and touch on that when we do the inside of the bowl as well, or the inside of the wig stand kit. Now today, like I said, safety first, protect your face. I'm going to be wearing safety glasses just in case anything gets under my safety shield. And I will be wearing my face shield as well. And I will be wearing earplugs. So don't worry, if there's any questions, I can still hear you. It will be slightly muffled, but I will quickly shut the lathe off, take my earplug out. You can reiterate the question, and I will answer the question right then and there, okay? Now let's make a mess, okay? All right, everyone can hear me?
Yep.
Thumbs up,
Yes.
Perfect. Okay. Now, whenever you set up your material, I set up my tool rest at a 45-degree angle to that corner. And when I start making these cuts, I start cutting here and I take off that corner, 1/8 of an inch at a time. Next, 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 and then final cut. That's if I want a straight pillar across the top of my wig stand, but we're going to shape it slightly, give it some curve, give it a little bit of flair. Always spin the piece of wood to make sure it's not going to hit your tool rest, because if it hits your tool rest, it can damage your lathe. It can hit the tool rest. It's stuck within my chuck, so it can damage my chuck, damage my live center. But if this was between centers, it would hit the tool rest, it would bounce off the lathe, and it would be airborne, potentially hazardous, okay? Also, whenever I am turning, I am not standing directly in this line of fire. I am always off to one side or the other. If this were to come off, okay, it might hit my shoulder, but it's definitely not going to hit my face, my neck, my sternum, okay? And 9 times out of 10, you'll be able to duck quickly, okay? But always take the proper safety precautions. Now, when we start the lathe at a slow speed because we want to make sure that this piece is as balanced as possible. We don't want it shaking, rattling, and rolling across the floor as we're turning, okay? And when I start the lathe, I listen. A lot of us rely on sound as well. Sound will tell you how thin you're going, how thin you're getting. It will also tell you if there's a crack or a click or a wobble or a hum. A wobble or a hum, the piece isn't quite mounted, balanced, and safely. If there is a crack or a, you definitely want to shut down the lathe quickly and re-inspect your piece of wood for cracks. Now, life's too short to turn cracked wood, and if you turn cracked wood, the centrifugal force can pull that crack apart, and it could potentially shorten, cause injury, okay? So now when I present this tool, always anchor the tool to the tool rest first. I angle the tool at a 45-degree angle in the direction I am cutting. I line up the bevel to where I am creating that cut. Because if I line it up to enter that cut with the wing, if I am too aggressive, you can bury that wing, giving you one hell of a catch. But by lining up that bevel and cutting with that bottom wing, you're severely avoiding a catch. And when I use this tool, I don't have my arms out here in airspace because you will get tired very quickly. And when we get tired and fatigued, that's when accidents happen. You want to anchor it, line up the bevel, lock it into your hip for stability, and just move your body across the timber. Far less variables to move that tool to slam into the wood to give you a catch, but also your legs are a much bigger muscle group. They won't get tired and they won't get fatigued. And you won't have accidents happen due to tiredness and fatigue. Okay? We'll go to this view. So I anchor. Now, how you hold the tool on your tool rest is your preference. You can do an overhand, underhand, thumb, however you like, whatever is comfortable for you. It all comes down to woodturner's preference. Okay. So I enter my cut, lock it into my hip, cut with that bottom wing, 1/8 of an inch at a time. Now at the speed I'm turning, it will be take quite a long time to get where we need to be. So I'm going to speed this up. Got a little bit of a wobble there. I'll go right past it. And now we're spinning balanced. Now people ask me, what speed am I turning at? I always say, turn at a speed that is comfortable for you. You might not necessarily be comfortable turning at a speed I turn at, so turn at a speed you're comfortable turning at. Faster speed, sharp tools, you will get a better finish off the tool, but you don't have to turn at a fast speed. The faster you turn, the higher the risk, okay? But just to let you know, I'm turning at about 1,000 RPM. Enter bevel. Once I'm on that bevel, just ride that bevel. Cascade across the piece. Constantly keeping your face, neck, and sternum out of that line of fire. Okay. I'll take a quick peek to see where I'm at. And we can see I'm slowly inching my way back to make that square stock round. And by cutting into that face grain, across that end grain, I'm cutting downhill. I get a really nice finish because the fiber underneath is supporting the cut being made above it. Okay, so we'll rough turn this quickly, round. Now you want to enter at a slow rate. You can speed up slightly. And you want to exit at a slow rate. Or you can leave that little lip there and you can come back this way and you can get it as well. But as long as you make a slow exit, you won't have a significant amount of tear out. If I am coming across that timber too quickly and I'm too aggressive, once I get over here to this face grain, if I'm too aggressive, I can pull that out. And again, I will have a sliver right here flying through the air, okay? Probably land in your hand, okay? Now we can see my tool rest is getting further away from this corner. You always want to keep the leverage in your favor. So we need to move our tool rest closer to the timber. Now it's okay to move your tool rest. I just highly recommend you shut your lathe off first, okay? Because if you miscalculate or it's a little sticky here and you're like, oh, it's sticky. Oh, now it's in that corner. Now it's caught and this potentially piece of wood can be airborne. So it is a very good safe practice to always shut your lathe off to move your tool rest. You always want more of this tool on this side of the tool rest rather than that side of the tool rest. Otherwise, it will be like a teeter-totter. And every cut will give you a lot of vibration and resistance. And then catch, okay? Nice and slow. Now the key is good sharp tools. Let the tool do the work. You don't want to force it through, because if you force it through, you're going to tear those fibers anyway because you're moving faster than it's revolving. You're forcing it across and splitting those fibers. But also the tool is going to heat up quicker and it's going to dull a lot faster, okay? Slow exit. Now I think we're pretty much round. We can see here we're not quite square, and we true this up once we have made it our recessed mortise or reverse tenon. So I have this pretty round. I have a little bit of a flat spot here and here, so one more pass. And then from there, I need to true this up, create my mortise, then I can flip it and I can start turning the inside of my wig stand. Now I'm going to shape this once I go to do the inside. Now I need to make this square so it will sit flat and reference flat against the chuck jaws of my lathe. And you can do that two ways. You can do it in a scraping action like this, where I am scraping with the bottom flat portion of the tool. And as I scrape with that bottom wing and the flat part, I don't contact both points. In fact, if I had a business card, you could fit a business card between that top blade, okay? You don't want to contact both because you're going to dull both surfaces. Also, you don't want to contact both because if you over rotate, you can catch the wing on the top. Now, on the contrary, if you open this too much, you're going to catch that wing on the bottom. So you want to make sure you keep your flute closed and you're scraping with the bottom portion of that tool. Okay? Now, you can go from the outside in to the center. You can start from the center and exit, or with a little bit of practice and confidence, you can go both ways. Okay? Now that would have been a scraping action. Now with scraping, you dull your tools quicker, and you usually have more sanding. You can also do that with a cutting action. And if I do a cutting action, I line up my bevel here. I enter with that bottom wing, and I cut across that surface. Now you can make it slightly concave or perfectly flat, but you don't want it to be convex because we want this to sit flat. Okay. There. Now I have a flat surface that I can now make my mortise or tenon in. You can take a ruler, you can double check it, and we can see I'm not quite flat yet. If I left it like that and I made a tenon there, I'm going to have a drunken wig stand or a wobbly bottom to a bowl. We want that to be flat or slightly concave. So one more pass. Now you can see here, I'm creating a beautiful spiral design. In fact, I just made my bowl gouge a chatter tool because as I come across, I have more tool overhanging on this side of the tool rest than this side of the tool rest, which chatters and moves and gives you that beautiful spiral design we don't want. So we need to remove that, and how to do that is we move the tool rest much closer so the leverage is in our favor. Okay. I know here I'm concave. Let me just switch here. So I know right here, because of the ruler, it's concave. But in here, it's convex. So I don't need to start at the outer edge here. I can ride the bevel right here where it's not cutting. I move the handle away from me towards my tailstock to initiate the cut. And I'm cutting with that bottom wing. There we go. If you like, you can also scrape it. Totally up to you. Oh, it almost fell. Now we can take our ruler again, and we can see now it's perfectly flat. Okay. I have a little bit of a bloop here. That's the technical term. So we'll just take that out with one final pass. There we go. Now I know we have a perfectly flat surface. Now, since I have this within my spigot jaws and not between centers, I can remove my tailstock, and that will allow me to create my recess or a mortise for my chuck to go within and expand to hold the piece so I can do the inside. Okay, and I'll do that now. Set up my tool rest straight across the face of the bottom of that wig stand base or bowl, so to speak. Now I use my parting tool, and I'm going to create a recess into that wood that will be held with the chuck. Now I'm going to be using a one-way stronghold chuck. So I enter at center, and I go straight in. Again, straight in, and I work my way across to give me a flat surface within that recess. Now you could do a traditional tenon. The only thing is that we would have to put this back in the spigot chuck to then remove that tenon. So by using a mortise or a recess tenon, we don't have to flip it a third time to remove a tenon. Okay. Here we go. Now I can start here, angle the tool, and you can use it like a skew to flatten that surface. Just like that. Okay? A parting tool is just a miniature micro skew, if you love your skew. And I sure do. Okay? So I'm using a one-way stronghold chuck today. So my ideal tenon or mortise is 2 inches. Excuse me. It's 2 inches. So I'll just double check that now. Here we are. What are we at? Oh, I'm at 2 1/4. That's perfect. Okay, 2 1/4. You want that to be within 1 7/8 to 2 1/4. Now that is a perfect circle when my chuck is open. And that will give me the strongest hold possible because all points of contact of the jaws of my chuck will be in contact with that surface expanding to hold the piece. Now, if we do a recess tenon or a mortise, you have to keep in mind we need enough wall thickness on the perimeter to withhold that expansion pressure. If we make this wall too thin and we expand that pressure, if there is any catch or too aggressive on the inside, that wall will blow out, it will break, and this piece will be flying through the air. So you want to make sure ample wall thickness that is able to withstand the expansion pressure of the chuck if you were too aggressive or had a catch on the inside of this wig stand base. Now, how deep do I make my mortise? You can get away with a 1/16 if you have no catches or you're not too aggressive on the inside. You can get away with an 1/8. Also, if you're not too aggressive and have no catches on the inside. But the maximum depth would be 3/8 of an inch, because the distance from the top of your jaw to the bottom of that jaw is a 1/2 inch. So you don't want to be bottomed out on this surface again, because if we get a catch on this corner, say this is already flipped and in the chuck, and I get a catch on this corner. If this is bottomed out within the bottom of that chuck, it gives it leverage to pop itself out of the chuck, and again, it is now airborne. Okay? So I make mine roughly an 1/8 of an inch or less. I'm going to make it a little deeper, just in case, because if anything goes wrong, it's going to go wrong in a demo. Here we go. Slide across like your skew. Clean up that surface, and we're good. Now, at this point, I would sand that surface slightly. Not going to do much sanding. Now, you don't want to sand this wall too much, because we don't want to change that profile. Now, if you're using dovetailed jaws, you want a dovetailed recess. If you're using straight-sided jaws like I am today, you want straight-sided recess. There is no benefit to using straight-sided walls on a dovetailed recess. It is actually weaker because it will compress the outer edge before it even contacts that inner edge, and you don't have a strong hold at all. Okay? Yeah. And
Kate,
once
I
I've
have
done
a
that,
question.
one thing I do when I do the wig stands, you can make that little recess a little aesthetically pleasing. But what I do is I take my skew and I create 3 little lines where I label the type of wood, I sign the piece so the individual know who made it, where it came from, and then I also sign the club. So in this case, it is from the Durham Woodworking Club, made by me. The wood is ash, and all in all, it was donated by me, but by the club as well, to your Cancer Support Center. Okay? And that really frames it in nicely. Okay?
Kate, I have a question. Can you hear me?
Yeah, I can hear you.
He said, Paul is asking how you create a recess if you started by using a spur drive.
Yeah, that's a good question. If I started just using a spur drive, that is why I would have my tailstock support here. I would make my recess just the same with my parting tool.
We need the overhead camera.
Oh, yeah. Sorry. All right. So if I didn't have it in my spigot jaws and I just did it between centers, I had the spur drive and my tailstock up here. What I could do is I would create my recess just the same, inching my way back until the tool hits my live center and I can't go any further. After that, I then switch to my detail gouge or my modified bowl gouge. And within that recess, so I would create that recess here. And I would recess maybe 2 or 3 times until this hits my live center, and I can't go any further in that direction. At that point, I would lie this bevel on that flat surface, and I would cut towards the pin. You can enter this way to remove the bulk of material, and then work your way across until you're only left with a very small pin. Then once you remove your tailstock, you snap that pin off across the grain. That way it will break off cleanly. If you break it off with the grain might curl up this way or curl up that way. And if we break it with the grain, it might sever underneath that surface. But by breaking it across those grain fibers, it breaks off cleanly and above the surface. And then I would just take my sandpaper and I would sand that tiny little nub off. But I wouldn't remove that nub until I'm done everything here. My final step would be make the recess, blend it to a fine pin. Then I remove the tailstock and the lathe is off. I now take this off, I break that off, and I sand the nub off. That way this is still bound between 2 contacts until I'm finished. And then once I'm finished, the lathe is off. This is off the lathe, and I just sand the nub. That way there's no potential hazard of this coming flying off the lathe. Okay? It's just a little more fussing around, but it's totally possible just between centers. Okay? But it will depend on your experience and comfort level, because as we approach that pin, the thinner that pin goes, you don't want to go through, you don't want it to break off, you don't want to get a catch and it severs, because this could potentially wobble and come off. Okay, so it would be a little bit of a higher risk, but it's totally possible with the proper tool control, technique, and skill and confidence level. Okay. Now to make my little lines in there, you can do that 2 ways. You can do it with an awl. If you have an awl that is sharpened to a point, you could also do it with a point tool. Okay, you could also do it with a skew. Now the only thing is, my tool rest as it sits now, if I did it, I would be pointing the tool upwards and I would get a very violent catch. So you want to be cutting at center, and you can go straight in, straight in, straight in. I'll show you once with my awl. Okay. And I go straight in. Now that is how I would do it with the awl. And I would do a series of lines equally spaced apart, which would be where I sign my name, label the wood species, and I sign the club. Okay, now you can also use your skew. If I use my skew, you're not going to use it up like this, because that curve will catch and it will give you a beautiful spiral design all the way out that surface. Okay, we don't want that. We want to keep our nice pristine surface. We only want to make lines within there. So to do so safely and efficiently without getting a catch, we use it as a negative rake scraper. We enter with the tip and we have it at an angle. So the angle is equal on either side. So this angle and this angle will cut a perfect V if I present it properly. Okay, and I just enter into that line, and then I move out. There we go. Now there's my positioning for where I'm going to label it, sign it, and whatnot. At that point, I would touch it with a light sandpaper again, just to clean up any fuzzy bits. And that's it for sanding. With good tool control, you have very little sanding. Okay? So that's it for now. We're done with the base until we flip it to do the inside. So rather than switch out chucks to do the base and finish the base, we might as well prep the top part of the dome and then just switch chucks and flip it around once. Okay? So now I closed my chuck. Move all my tools and rulers and stuff here. All right. Any questions so far? And this will just pull off. Now keep in mind, you don't want to be pulling too crazy that it pops off and this elbow slams into your live center. We want to remove this to avoid that. When that hits your funny bone, it's not so funny. Okay? Also remove your tool rest, because as it sits now, if I pull this, I might bang my knuckles across the tool rest. Okay? There. Now all hazards are out of the way. That just slides and pops right off. Okay? Yeah, this camera. Let me see here. There, that's better. Okay, now we have our base done. We have the recess, which is going to be held to do the inside. I'm going to hold it there to shape this and give it some curve, some shape, some beads. So now I do the exact same with the top. Oh, I'll close that. Here we go. If you have a turner mallet, you can use your turner mallet. And we can tap that on. Or, if you don't want to find your turner's mallet, just bring up your tailstock, lock it in, tighten that down, and that will force it to the bottom point of that spigot jaw. Now we do the exact same thing in turning this piece. Again, it's just like the outside of a bowl. This one more so than the base, because this needs to have a nice curve or a dome that your wig stand sits on. Okay? But we also need to create a tenon so we can hold it while we do that. And in doing so, we always give that a spin. Tool rest 45 to that corner. Give it a spin, make sure it's not going to hit anything and become bird wood where it's flying through the air. Slow down your lathe, start the lathe. I'm standing off to the side. I didn't hear a crack, a wobble, a hum, so I know it's structurally sound and it's mounted the way I need it to be mounted. And now I turn the speed up on my lathe to a safe speed that I feel comfortable turning at, which is at 1100 RPMs right now. Okay, just like before. Now I moved my tool rest, okay? Because when I use the parting tool, you want to be closer to center and you're cutting at center. Now, since I'm using a bowl gouge, I want to be below center. So when I'm cutting at that center point, okay? Anchor, line up the bevel, initiate that cut, just inch your way back. Now that's a roughing cut, which is at a 45-degree angle in the direction you're cutting. You can also do a peeling cut, which removes a lot of wood very quickly. Now when I do a peeling cut, my tool rest is below center. I'm cutting above center, but now I am cutting with this wing. Actually, I'll switch to this camera. So when I'm doing a roughing cut at that 45-degree angle, I'm riding the bevel on the nose of the tool. Okay? Yep. And then with a peeling cut, now I am riding the bevel here on this wing. Okay? Between here and here. So the tool is low, the nose of the tool is high, and I am riding the bevel exactly right there. Okay? It will remove a lot of wood very, very quickly. Okay? The only thing with that peeling cut now, you got to make sure you stay on that bevel and move that tool back and forth. You don't want to, by any means, rotate that tool towards the wood, because now we've exposed that wing, which will bury itself in that wood just like that and catch. Okay? So your peeling cut. You're at the same height as about a shearing cut, okay? I enter and I ride that and I just peel that wood away. Down here, I can return to a roughing cut and just round that round. Now it's a little rough. That's okay, we're just roughing it. We're giving it a rough shape. Our final pass is always our finishing pass. Now I can round that first, or I can shape it and round it at the exact same time, because we are still cutting downhill and we're cutting from the top of the dome to the base of the dome. Cutting downhill, the fiber below is supporting the cut above, so we have very little tear out. We have a little bit here because it's on the uphill as the end grain is coming this way. Very nice finish, and again, uphill slightly, but our final finishing pass cleans that up quite nicely. Oh, my tool rest is a little far, so I can actually move that a little closer. Now also, the reason I switched to a peeling cut is because I can only get my handle so far before it hits my tailstock. And I can only ride the bevel so far making that cut in a push cut. Slow down as we exit so we don't have splinters flying through the air. Okay. See, I can't get close enough to ride that bevel. I would actually have to start over here, and my tailstock is in the way. So by doing that peeling cut, I can get right in there, and I can come down around that corner and shape the dome of my wig stand. Turn it, 45, rough and cut. You can do it all in one. Peeling cut, bring it down and around, rough and cut, and exit slowly through the bottom of that dome. Now we have a nice curve to our dome. We need to create a tenon so we can hold this, so we can hollow out the inside. First thing we need to do is flatten this surface so we have a tenon that sits flat, true, and square in our chuck. Again, we can do that in a scraping action like this. Or you could also do it in a cutting action, just like this. Slowing down and stopping before you hit that live center. Now to create our tenon, I'm going to enter with that bottom wing, enter and close my flute to give me a nice right angle for my chuck to reference against. Okay? Close your flute. Enter, close your flute. Now you can come across, my flute is at a 45. If I continue to keep that flute open, you can see this bottom wing is approaching that wall. If I neglect to close that flute as I approach that wall, you will catch and you will bury that bottom wing in that wall, giving you a catch, and potentially it's a design opportunity, or potentially it could come flying off the lathe. Now again, your perfect tenon here is 2 inches. So I'll just double check that with my calipers. And I'm at 2 1/16. So that's perfect. That's a perfect circle to be held within my chuck jaws, giving me a maximum hold possible to hold that piece. Now, when I have a tenon, I'm using straight-sided tenons. So I want this corner to be a perfect right angle. And it's hard to do so with an Ellsworth gouge or an Irish grind gouge because of that wing on the bottom is curved. Excuse me. So I changed to my modified bowl gouge. Now this is a 1/4 inch Thompson bowl gouge that I modified to be flat across here, and I still have that 60-degree bevel angle here swept back to 120 degrees. The only thing is I removed that bottom wing because I want crisp right angle corners on my tenon and my foot. If I were to do a footed bowl, you want crisp, tight right angle corners. Okay? So this is what I use to really clean up my tenons and my feet. Okay? And with this, I enter the exact same way. If I were using that bowl gouge, 45 direction I'm cutting, ride the bevel down, close the flute as I approach that wall. And I can scrape outwards. And now we have a perfect right angle. Slightly concave. You don't want this convex because if you have a heel as it approaches that tenon, your chuck won't seat properly and flat. It will be off. And then when we turn the inside, if it's off, we're going to have one thick side and one thin side. With a thick side and a thin side, added vibration, added resistance, and you're probably going to measure the thick side, forgetting about the thin side, and you'll go through the wall. Okay? So you want it as mounted as possible. You want this tenon to be perfectly right angle, flat on both surfaces, so when I flip this and put it in the chuck, it's going to be spinning just as true as it is between centers. Okay? Now all I need to do is I just need to blend the dome. Make this perfectly round, bring it down to the desired diameter, which is between 3.5-inch diameter up to 5-inch diameter. Any larger than 5-inch diameter, you can start to stretch and disfigure the crown of that wig. Okay? A 3.5-inch one is more of a younger woman or a teenager or children. Cancer doesn't discriminate on age, so they're needed everywhere, okay? So now to do so, to blend this, again, I can't get over here to ride the bevel because my tailstock is in the way. So I can ride the bevel here, come around and create my dome. But from here to here, I have to do a peeling cut to blend the top of that dome. But we also need to keep roughly 1/8 of an inch shoulder so your chuck can seat up and reference on that flat shoulder, which is a square right angle to your tenon wall. Okay? Any questions so far? How's the video?
It's breaking up fine, but your volume is good and it's really not interfering with what we're seeing.
Okay.
It's just
no interruptions with the mic and talk. It's just the flashy video on the one camera.
I think it's on all the cameras, Kate. I think it's from the weather that's in the area.
Okay. Well, when I watch it to edit it, if it drives me nuts, I'll do another quick video this afternoon, and I'll send that one out to everybody. Okay? Okay, thanks, Tony. That's good to hear. Okay? So we'll keep going here.
Ruth said it's coming through great, so.
Pardon? Sorry?
Ruth commented and said it was coming through great, so I wouldn't worry about it.
Okay. Okay.
Don't let it interfere with what you're doing.
Okay. No
Everybody,
problem.
well, I mean, we can understand and follow. It's just.
Yeah. All right. So we'll continue. We'll get that round quick. So here I can do a bevel rubbing cut. Now right now I'm just roughing it out, so I can take a fairly heavy cut. Now the heavier the cut and the faster the feed rate, you're more likely to get that tear out as that grain alternates from downhill, uphill, downhill, uphill. But your final pass, when you do that finishing cut, you only want to take roughly a 1/16 or a 32nd, if that. And that you'll have far less resistance far less vibration, and far less likely of having that tear out that everybody hates to sand out. Now that tool is dull on the one wing, so I'm actually going to switch to my other tool, which is still sharp on this side, and then when we do the inside, we're going to use the right side of each wing, so we still have two tools that are totally sharp. Okay. Oh, look at that sharp tool. Now we're round, okay? Now all I need to do is blend the top of that dome, and I can do that in a peeling cut. There's those peels coming off. Okay. Okay, now there's our dome. We have it shaped, we have the curve, we have our tenon, we have the shoulder for our tenon. Now all I need to do is really refine that surface to give me a nice finishable surface. Okay, and to do so, I can do a peeling cut in a very light cut, or you can also do a shearing cut. I'm just going to move my tool rest slightly. Now with the shearing cut, your tool rest is below center, your tool is above center, and we are shearing across that flat surface, down here, the flat surface of that tool. And by doing so, we have it at a skewed angle. So the timber comes across that cutting edge at a skewed angle, giving you a very fine cut and giving you a really nice finish, which has minimal sanding. Okay. And I'll show that cut on this camera, and then I'll show the cut on the other camera. And that's what you want. You want these fine angel hair pasta primavera. Very fine curly cues. Give you a really nice finish. Here we go. And I'll switch again here just to blend the two. That's pretty good. Very nice, finishable surface, minimal tear out. Actually, no tear out. Look at that. At this point, I would sand. Just sand lightly. I'm not going to sand much. Now, when I sand, I would definitely be wearing a respirator. Protect your lungs. The dust is not good for you. Once it's in there, it doesn't disappear, it doesn't decompose, it doesn't dissolve. It's there, okay? So I would be wearing a full respirator. And when I sand, remove your tool rest, because you don't want any chance of your tool rest becoming in contact. You don't want your hand getting pulled in by the friction of the sandpaper and caught in between the wood and the tool rest. The wood will burn, the tool rest will cut, okay? So remove your tool rest, and what I do is I rest my arm on my tool rest. I don't rest it over top of the tool rest in case I do get a catch from the friction and it pulls me down like this because you don't want to articulate your wrist in any way. So I hold it off to the side and I support my wrist on this corner, just for a point of contact and stability, okay? From there, I also anchor my arm and I just move the sandpaper back and forth. Now, if I sand down here, you can see the dust is going away from me. I would also be using a dust collector, okay? You don't want to sand up here because now it's throwing all that dust right in my mouth, okay? We'll lightly sand that. That's pretty good. You would want to go through the grits. I started at 180 and this is 220, and that's good enough for now. Okay, now we have our dome and we have our base. We have this that is perfectly flat or slightly concave. We have a tenon that is a perfect right angle to the shoulder. And we have a nice domed surface. Now, when I remove my tenon, I'll talk about it when I remove my tenon. Okay? Now we can remove our tail stalk and our live center. We can loosen this off. Yep. Now we want to remove our tail stalk because, again, we don't want our funny bone to hit that nice little pointed piece of metal that feels so good when we kiss it. Also, tool rest out of the way. It'll wiggle right off. Okay? Very secure, very tight hold, very safe way to turn this project. Okay? So now I need to switch to my stronghold chuck so I can take out my spigot chuck. Now, a rule that has always been instilled in me by my teachers and mentors is hand on the chuck, it's in the chuck key. Hand off the chuck, your chuck key is back on your workbench. You don't want to have that in there, forget, get doing something, come back and forget that's there. Start your lathe, you're going to have an anti-tank round flying through the air. Okay? So hand on the chuck, hand off the chuck, it's back on my tool rest. Now when I remove this, I hold this stationary and I move my back wheel. That way I'm not going to strip, mark, and mar the threading on my tailstock. Okay? And also, when I put this one on, I hold this in place, supported and anchored with my tool rest, hold it in place, and I turn the back wheel so I don't strip the threads of my chuck. Once it's almost seated, I give it a little turn just to make sure it's seated flatly and securely on those threads. And in doing so, you'll significantly reduce any risk of ruining the threading on your chuck adapters or your tailstock spindle. Okay, what to do first? You could do either one first. Depends on your preference. I usually do the base first, but it doesn't matter. Oh, look at that. I made my recess a little too small for my jaws. So what I'm going to do is I'm just going to put my spur drive in here. It's good to have a miscalculation and show how to fix it. So I bring this up, bring my spur drive into contact here. I can bring up my tailstock for support in the very center of that pin. Or I could put this back on my spigot jaws and it would be perfectly balanced. Doing it this way, it might be off slightly. And it might be slightly out of balance. So if you want to be very precise and accurate and not have to true anything up, I would just put your spigot jaw back on quickly. There we are. Perfect. Open this back up. That ain't spinning true. We're slightly out of round. That's okay. True this up quickly. Do that in a scraping action again. We'll check, make sure we're flat. We're good. Now I have it in the spigot jaw, so I can remove my tailstock. I'm going to touch that up again with my parting tool. And funny enough, I only need probably a 16th or an 1/8 more. A very slight miscalculation, but that's okay. Okay. At that point, I'll make my marks with my skew again, just to frame everything in. There we are. Move my tool rest. And lightly sand this one more time. There we go. Now, we'll measure twice. Cut once. There we are. Now I got enough space. And just in case, I'll do that extra 16th. There. There we go. There, now we're cooking. Now, all right, any questions so far?
I haven't had
Alrighty.
any questions in the chat, but if somebody wants to unmute themselves, they can ask a question.
All right. So now I'm just going to clean up the outside here, give it some shape, maybe a bead, a concave into a bead, or you can shape it and beautify it however you see fit. I've done a wide variety of different styles. You could do burn lines with a hanger wire or a guitar string. You could do beads, coves. The design opportunities are endless. So the first thing I'm going to do is I'm just going to clean up this surface. I'm going to leave it a little proud at the bottom because I want a little bead at the bottom. Now, since we're doing side grain, end grain, side grain, end grain, you're going to want to use a bowl gouge or a spindle gouge. Now, you could use a skew if you were really efficient and proficient, and you can ride the bevel, but I highly recommend not using a skew on alternating grain, because if you get a catch and it catches that end grain, it's one very violent catch. It's possible if you're efficient with the skew, but keep in mind if you're not, or you get a catch or misplace that tool in any fashion, it is one very violent catch. So use a bowl gouge or a spindle gouge. Okay. First thing I'm going to do is just clean up that surface with my sharp bowl gouge. I'm going to start by dishing this out slightly. Now I don't want to do that too often because I'll be doing this cut, I'm cutting downhill because I'm cutting down and across those end grain fibers. If I cut in this fashion in that direction, I'm cutting straight into those end grain fibers and across the fibers. So I'm more likely to get a catch if I come in this direction and across that way. And by starting and just moving my body to the left, that creates that concave. So I enter, and I just move my body across like this, and that arcs that tool to give me that curve. Yep, everybody gets the recording. Okay, I'm gonna come across the surface here just to clean up that surface. A very nice light cut, maybe a 16th, will really give you a nice finish on that end grain.
Kate,
Now I
could
want to
you put
shear cut this to give me a good finish.
Kate,
I
could
have
you
the
put
tool
the
high.
overhead camera on?
Yeah, sorry about that.
Thanks.
So I'll just show that cut again here. I enter, I arc the tool away towards the tailstock to give me that arc. I came across with a 1/16 of an inch cut just to finish that surface up. Now I want to shear scrape this edge to give me a nice finish. Okay. Now you got to stay on that bevel or on that shear, because if I open this too much and I present that wing, that end grain will let you know it's presented wrongly. Okay. I'll just take a pen here, make a line. If my pen worked, it's all right. I got a few pencils here. There we go. Do one there too. Okay. Shut this off, take a quick peek. There we go. Nice finish. We cut downhill across those end grain fibers. We did a shearing cut to really clean up that surface, give us a finishable surface. Very little sanding. Now I'm going to create 2 beads here, 1 bead there. You can do as many as you like, but an odd number is most aesthetically pleasing to the human eye. Also, I'm going to soften this corner so it sits on the table a little gentler, just a little bit nicer. Okay, so I'm using my detail spindle gouge now, which is sharpened at 30 degrees. Now to initiate my bead, I start at a closed position and I enter with a stop cut. Just going to move my tool rest up because I want to be cutting at center with this tool, but the tool I was using before was much thicker, so it is lower when I'm using this tool rest, so I'm cutting at center. It's a little higher as the diameter of that steel gets smaller, so I'm still cutting at center, okay? So here I'll do beads. Right here I'll do a burn line, and I'll round the bead over into the dish of the cup. Okay. Now when we create a bead, and we're cutting end grain, you don't want to be on the downward centrifugal force if you get a catch. You want to be slightly above center, then it's less violent of a catch, and that end doesn't get buried as deep into the wood up here as it would down here at center. Okay, now I could keep that at center and just tilt the tool upwards to create these beads. Okay. There we go. Come on this end. There we have a nice connection there. Roll that over. Now I need to do the bottom to soften that edge slightly. Okay, and then we'll round this edge over slightly. Nice light cuts. And around that bead into that curve of that concave. There we go. Now sandpaper can clean up some of those edges, or if you're really picky or a perfectionist like I am, you can do one more pass, famous last words, okay? Now for this line here where I'm going to do a burn line, I could use the skew. Only because I'm presenting that skew straight on, straight up and down. You don't want to present this skew in any way, one way or the other, because it will skate up here or skate up here, and it will give you a violent catch in end grain. Here I am just making an entry cut so that burn line will follow that groove. And to do that cut, I enter with the tip and I just lift the handle and exit quickly. So to see that cut here, enter, lift the handle and withdraw. Lift the handle and withdraw. We don't want to keep that tip in there too long because it will start to heat up. That is the thinnest part of your skew, and it will heat up and lose that temper very, very quickly. Okay? So at this point, before I touch it with the burn line, I would touch that with sandpaper lightly.
Kade, Paul has commented that the glitchy screen that keeps flickering, he says he thinks it's your overhead camera. Maybe you have a connection is loose.
Yeah, I don't know. Here.
Is there a connection up to on the camera as well?
No, the connection goes into my USB box that goes into my laptop, but I've never really had much of a problem with that before. I can double check here again. Sometimes if I...
Camera.
Oh, Paul commented that it's only on the overhead camera that's glitchy.
Yeah, I know. And if it's not that one, it's the front one. There we are.
Well, that's better. That's better already.
Here, I'm just going to go back here and I'll zoom. Huh.
Still getting flashes.
Yeah, still getting a couple there. Try this again. just changed the connection, so took it out, cleaned it out, and popped it back in there.
That looks good already. Better.
Hopefully that helps. We'll
That
see
looks
if it's
good, Kade.
okay. Maybe if I just zoom in too much or something with that camera. That seems to be good. So, any questions? No? All right. So at this point, I would do my sanding. I would turn my dust collector on. Also, when I sand, I do a lot of production turning here and there. So to shut the lathe off and turn it on and to constantly change the speed, sometimes it's time consuming. So if you really get good tool control, you can start sanding and stop sanding at the speed you are turning at. But in a hobby situation, or if it's just for fun, I always say slow the speed of the lathe down between 300 and 500, and you will get a better finish. Now, at a slower speed, you're going to remove more material. At a faster speed, it looks like you're removing more material. It's just the dust is being thrown around by the centrifugal force of the lathe. Okay? So right now I've turned the speed down to 300, especially in end grain. If you're sanding end grain at a high speed, all the sawdust that comes off are just going to fill the pores of that end grain, and it's going to take you forever to sand that end grain. So if it's a spindle, I would probably sand at a faster speed. But it's always a good idea. Slower speed, you remove more material, and it's not thrown in your face. It goes to the floor. The only reason I sand the beads up here is I can see them, and I can see when I'm in the cracks. So I would be wearing a full respirator. Well, not a crack, in the crevice of the bead, so to speak. Down here, it's a little harder to see, and it's a little harder to keep it exactly in that groove, I find. But we all sand differently. If it works for you, it works for you. Just be safe and have fun, for sure. Okay? So that's sanded pretty good. Nice finish. Tool control. Okay? Now, you can create burn lines. The only thing is never wrap that wire around your fingers. Because if you got a catch, it could lop a finger off. Okay, so I wrap it around pieces of dowel. I hold these dowels like this, and when I burn this, I enter here, I hold the pressure to make the burn, and I remove it quite quickly before this heats up too much and snaps. Okay? Now keep in mind, when I remove this, if your table is full of shavings, don't just throw it on your workbench or your table, because this piece of metal will be almost amber hot. Okay? Hang it somewhere, put it in a safe spot so it does not cause a fire. Now for this, I would also turn the speed of the lathe up to what I was turning it. Enter the groove, hold the pressure until you see a burn, and release. Okay? You could do a series of burn lines, and you can add that to your arsenal of decorations. Okay? Now when we do a burn line, we might have a little bit of overburn, depending on the species of wood. So I always touch that lightly with a piece of sandpaper just to get rid of that overburn. Just to clean up those crisp connections and keep that burn exactly where I want it to be. Now keep in mind, I've sanded this corner so it's not sharp and serrated. But this corner, I have not trued up this front face yet. I have a corner converging at a corner, and sometimes end grain meeting side grain, you can get serrations. So you want to be very careful and mindful of that edge, because if you slip or touch it, it will cut. It will cut like a steak knife. The only good thing is that the wood will cut and cauterize at the same time because of the centrifugal force of the lathe, but it hurts like hell. Okay? I think I only did that once. So soften that edge. You can soften it with your sandpaper, or you can soften it with the tool. Okay?
Tom says that he uses popsicle sticks.
Popsicle sticks, yeah, you can wrap sandpaper around popsicle sticks.
I think for
Sorry?
the wire, I think to do the wire, to hold the wire.
Oh, okay. Okay, yeah, that makes sense.
Instead of using
That's a good
wire
way
or
to do it
some
too.
metal, I use popsicle sticks. They conform to whatever groove you make, and they do make a nice burn. And I'm new at wood turning, and I try to find the absolute safest thing that I feel comfortable with. And I find the popsicle sticks just feel so much safer. And if it does come out of your hand, it's just a very light piece of wood that goes down to the bottom. If it does have a catch, and they work
just hits
very
the
well,
floor.
dirt cheap.
Oh, that's a good idea. So you take your popsicle stick and you sharpen it sort of to a point, and
You
then
don't
you
have
stick.
to sharpen it; it will conform itself.
Oh, okay. That's a
You
good
put it
idea.
into
That's
the groove, and it conforms itself because it's pretty soft wood. I'm not sure what kind of wood it's made out of, but the wood is soft enough; it will conform itself. You don't have to touch it.
Oh, okay, cool. All right. That's a great idea.
Try it
Another
one day.
thing to that point, if you go to Home Depot or Home Hardware or Rona, Lowe's, Walmart, if you go to the tile section or the kitchen section, you can get these little swatches that are different things that, like, oh, you can check this tile to see if it matches your paint. You can check this tile to see if it matches your paint. And with this, I think these are Formica pads. Yeah. So it's almost like a tile synthetic material. And these don't burn. They're a plastic tiles type resin material. And what I do is I cut these to a point or different shapes. And now on the face. So if I wanted a bowl or a platter, and say I wanted to do burn lines within this surface, I can't hold a burn wire on that surface.
Right.
But what I can do is I can take these, very similar to your popsicle stick, and I will stick that in there, and that will burn a burn ring on that front face of that side grain surface.
Right.
Now to your popsicle stick, you could also use these, and these will last a lot longer. These don't burn. These
Right.
don't wear away. They just go in, heat up, burn the wood, and you remove them. So they will last a lot longer than a popsicle stick.
Right.
But I mean, if you have enough popsicle sticks and it's working for you,
You can
that's
order
a
them
good
off
idea
Amazon,
too.
a couple of hundred for like $5.
Yep. You can also use this on the side here. Now, when you go into Home Depot or Home Hardware or Rona or Lowe's into their kitchen center and you inquire, just inquire and pretend like, oh, I'm redoing my kitchen. I need some ideas for tiles. These are free. You can walk away with 5 of these in your pocket for free.
Right.
Yeah, just say, oh, I need to match the paint on my wall. I would like a couple different ideas. We're looking to do backsplash or tiling in my kitchen. And they'll give you a handful for free.
Thank you.
Yeah.
I'll have to try that. Thank you.
No problem. Now you reminded me of that. So I'm going to do a contrasting burn line to match this one on the side.
Thanks, Bert.
I'm going to match a burn line right here, which will frame that into one another. So that's a good idea, and it also gave me a good idea too. So thanks for that. All right, now we have our side done, sanded, finished. We did some beads, we did some burn lines. You could do coves, you can beautify it in any means possible. Creativity is endless, designs are endless. Now I have everything secure. Remove your tailstock because we don't want to kiss our elbow in this lovely point. So I remove it totally from my tailstock, and you won't be yelling at yourself later. Set up my tool rest perfectly across the face of the top of the bowl or the bottom of the wig stand. Same grain orientation, same rules apply. What was I going to do? I just lost my train of thought, but that's okay. So yeah, we take our tool rest. Oh yes, what I was going to do. Now we have this in our chuck. We had it between centers. Now, what I always do is I always take and I just do one extra little turn because I want to make sure this is tight enough. This is going to stay where it needs to stay in the chuck and not flying through the air. It's just a little bit of an insurance premium safety tip that I follow quite regularly because sometimes vibration can loosen your chucks. Most chucks are friction fit. So over time with the vibration, they can loosen slightly. Okay. Now I'm using my bowl gouge, so I am going to be set up below center. So my tool is riding perfectly at dead center. Okay. Now to come across this surface, it would be more beneficial to do a cut because it's going to keep my tool sharp and minimize my sanding. I could do a scraping action, but I need to remove my tool rest. If I'm doing a scraping action, I need to be supported here to make that cut in this fashion. But today I am going to cut this. So I'm going to enter, ride the bevel, cut across the face. Oh, my helmet's in the way. Nope. Okay. And come across, slowing down as I approach center. Now the center will be spinning at what your readout tells you. As this diameter gets bigger, the speed amplifies. So you need to slow your rate of feed as you approach the center of that spinning wood. And I'll show you that now. Here. I'm cutting at center. I enter with my bottom wing. And I cut across that surface, cleaning up my area. Now keep in mind, if I didn't soften this edge and I was too aggressive and I slip, oh, you're going to go right into that edge. So soften that edge first before you make this cut. And if I cut behind that softened edge, for some reason, just be mindful of that sharp serrated edge as I cascade across that wood, slowing down at the center. Now I need to soften that edge again because I don't want to cut and cauterize my hand at the exact same time. I can sand this at the same time. And now that surface you want perfectly flat or slightly concave. Now you can see there's a 1/16 of an inch of a gap. That's okay, it's concave. So I know it's flat, concave, where my spindle is going to meet, it's going to seat flat, okay? Now what I'm going to do here is I'm going to do another burn line to frame in this burn line on that corner. Now to do so, I can use the skew, but I have to be at dead center perfectly straight, because if I present this in any way, it will skate, it will catch. Your safest option would be your awl. So grab your awl, after all, wherever I put mine. Oh, right here. You could also use a point tool. Okay, so I have this perfectly flat, cutting at center. Okay, and I enter straight in. Okay, I made 2 cuts, one on the side of each other, just to make that groove a little bigger, so I can fit my tiny little Formica cards that I got for free at Home Depot. Now I can fit that into that curve. Now if I use it as it is, I'm cutting above center and it will throw this down and around. And I mean, this could cut, it could break, it could scare you. So again, I need to move my tool rest lower. So when I hold this, I'm cutting at center. You can see it on this camera. I'll be cutting perfectly at center, okay? Now this will make a burn line on a vertical surface. See? Just like so. It does wear away slightly, but that's okay. All I need to do is go to my discs, my belt sander, and sand that surface again. So I haven't used these much, but I guess they do wear away just like your popsicle sticks do. But again, they're free. So every month, just go in and say, oh, I'm redoing my kitchen again. Redoing my kitchen again. Okay, so now we have that framed in. I would sand this to remove that overburn and any fuzz. Soften that corner. Now when I make the base of my wig stands, I always dish out the inside slightly because it's a nice spot for people to put their jewelry, their rings, their watches, their chains, a wide variety of stuff. So I always dish out a small portion so they can put those items in. And in doing so, I use a Irish grind bowl gouge again. Okay. I'm cutting at center, so I need to lift my tool rest slightly, and I'm cutting downhill. So when I make my entry cut, we want our flute to be closed. If I have my flute open 45, it's going to catch and skate away this way, and it will ruin our nice edge, our nice burn lines, and what we just sanded. If I have my flute closed too much, it's going to skate away in this way, following that curve and skating that way. So you want to make sure you enter with your flute closed. Now when your flute is closed, your flute is perpendicular to your bedway, okay? Enter, we can see I've entered and my flute is perfectly closed and square. I'm in that groove and it's not skating away on me. At that point, I open the flute 45 and I cascade into my cut. Now I only want to cut downhill. Okay, stop at the hill. Ride the bevel, cut downhill, stop at the hill. Now I need to cut down again, cut downhill. So now I enter with my flute closed here, open the flute, and I cut downhill into the bottom of that cove. I then pick up my cut again, cutting downhill and stopping before I go back uphill. I then again ride the bevel and blend the curve at the bottom. Keep in mind, we need to keep enough wall thickness here to support our spindle, okay? So now we have a fairly nice finish, cut downhill, and we cut downhill. So we only have a little bit of inconsistency or torn grain in the very bottom where I need to blend the two. Now to do so, I could use my bowl gouge as a scraper with that bottom wing, and I just scrape across the bottom ever so slightly. Just like this. Now I'm just scraping across the bottom to blend those curves into one another. Now if you have difficulty doing it this way, you can always grab your round nose scraper. Now if you're using your round nose scraper, tool rest needs to be above center. We're cutting at center. So if I'm cutting at center and my tool rest is above center, you can see the handle is in a trailing mode. If I were to get a catch, it just goes, relieves itself. You don't want to use a scraper flat or angled up because that cutting angle will be far too aggressive. You will not be able to hold on to this tool if it catches. Okay? Now I cut downhill, start at the high side, cutting downhill, blend at the bottom, and then I do the exact same coming down this wall and cutting downhill, blending the two. Now the one thing you don't want to do is be in too tight of a crevice where you contact both edges of that curve. So if this recess is too thin, I'll do that again here. So I start cutting at center, handle in a trailing mode. I start at the high side and I cut downhill into the bottom of that valley. I stop. I then cut down this wall into the bottom of that valley. And stop. Now what you don't want to do, if that's too tight of a curve or too tight of a surface, you don't want to bind that curve on either side. It will be catchy, it will be grabby, and you can potentially get a catch. So when I'm coming down this wall, I am only using this portion of that tool. When I come down this side, again, I'm only using this portion of the tool. And then when I blend the bottom, I have enough space that I'm not kissing the wall here and here at the same time, because I don't want all 3 points of contact in contact. That will give you a lot of resistance and vibration and catch, okay? So when I blend the bottom, I'm only using the bottom portion of that nose, okay? So that's the base. That's it.
Okay.
Oh,
So Kate, I have a question from Paul. He
yep.
says, regarding decoration and added features of a wig stand for charity, do the cancer support centers or end users care that much more for a fancier piece? Or is it just the utility that is important? Also, is there any value to added in threading the spindles so it can be taken apart? Or is that a feature that will never be used by a typical user?
That's a good question. It is a functional piece. The real function of it is really just so they have a spot to rest their wig when they wash it, so it dries in a good climate that has good air and breathability to avoid any molding or mildew within their wigs. So it is a functional piece. It doesn't have to be beautiful or shaped or curvy. Some of the ones I do for basic designs are just very simple base with a dished out inside. The top doesn't have to be dished out. It's just dished out to remove some of the weight. So the weight is in the base. So it's sturdy on the table. Okay, it just makes it a little lighter. You can do a tapered shaft, a rod. I mean, a lot of people like many different things. So the beauty is in the eye of the beholder. There is a variety of different spindles that you can do. And I mean, it totally comes down to design and how you would like to turn those pieces. But really doing the shaping and curves and beads and valleys and coves, it's really just for me, for practice, tool control, aesthetics. It's fulfilling for me to make something nice or visually aesthetically pleasing. And it's also really good for me to help people out in need. So they're not too worried about the design aspects because they're going to love it and enjoy it no matter how it looks, because it's helping them through their journey. But it's just a sense of, do you want to practice your beads? Do you want to practice your coves, your valleys, your design elements? Yeah, so it's more for you, creating and practicing, and they're going to love it anyway. Yeah. So, oh, and threading, the aspect of threading. That's also a good question. It would be beneficial. I mean, if people travel, it would be beneficial if people travel or move or go and visit people and they need to take their wig stand with them. In that instance, it can be screwed apart, tucked in a suitcase, and it can travel quite nicely. It's good practice. It's good technique and tool control for you practicing your threading. I just haven't really found a need to thread them. I usually just glue them and recess them. You can also make them a really tight pressure fit so they pop apart and pop together if you wanted to do the aspect of maybe traveling with it. But I don't really see a benefit to it. Well, it could be a benefit to yourself to practice, to get better at threading. If you knew someone who still likes to travel within their journey, it could be beneficial. But sometimes with chemotherapy and radiation and losing your hair, it's quite devastating, and you don't really feel the best. So traveling and having a wig stand that can pop apart into 3 pieces might not be on your mind.
Okay, this is Trace. Yes, you do travel. I'm a cancer survivor, and I drove a full day to get to MD Anderson to the cancer center.
Oh,
So
okay.
cancer patients do travel to get to the proper medical facilities that they need to get treated. And when we talk about threading, I saw somebody that did some that used metal inserts.
Yep.
Threaded metal inserts, and he did that because he could ship them. They break
Okay.
down for shipping, and they pack easy for shipping.
That's a good idea too. I mean, when you travel for treatments and stuff, would you really take your wig stands and wash your
Well,
wig?
I never lost all my hair, but I'm sure they'd bring their wigs with them.
Yeah, they
You
would.
bring a wig with them, so it could it would unscrew easily for traveling. But I did, anytime I went for treatment, I was traveling. So
Okay. Yeah, that's a good idea. I mean, if you do travel or you have to travel and take your wig stand with you, I don't know if there would be any reason to take your wig on or off to go to a treatment. But if there was, I mean, you could totally bring your wig stand with you.
You always spend at least 2 or 3 nights there going back and forth.
Oh, okay. So in that
Okay,
case,
it's a full day. It's a full 8-hour drive. So you're going to spend the night and everything. So.
Oh, wow. That's a bit of a trek.
Hey, you got to go to the right places.
Trey.
It's your life. You got to go to the right spot. So.
Yeah, that's a great idea. Doing the threading inserts or threading it or having it break apart. I never thought of that aspect, but thanks for that. That's a great idea. Yeah.
Thank you.
Okay. So we'll get back into it here. Now that I've done this, I've shaped all this, I've dished out the inside, I have a flat surface that was slightly concave here. The only thing I do is I make a slight taper. Now, the only reason I make that slight taper is because when I put that spindle plug in there, there might be excess glue and squeeze out. That little recess and cavity will catch that glue before it squeezes out and makes a mess of the surrounding area of your wood. You don't necessarily have to, but it will also instill that right here isn't higher than out here. So your spindle is going to sit flat and flush within that connection. So to do so with that, you can do that many different tools, many different ways. I just take my bowl gouge and I scrape from the one corner into the hole just to create a slight taper, okay? So now we know that when we connect that spindle, it's going to connect on this outer edge. You're going to have a seamless connection. You're not going to have a drunken spindle that's off to one side. And if you have excess glue or squeeze out, it will be all caught within that trough rather than squeezing out all over your nicely sanded finished wood. Yeah. I wonder where you get those metal inserts from, Trey. That's a good idea.
I didn't have it, but one of the people on Worldwide Wood Turning, I think some British guy was using them. But some of these different cabinet supply places and that kind of stuff, I know they'd make a metal screw in, and then you can have there's a piece of metal that's threaded on one side and has a screw thread on the other side. I've got some of those. So you put that on one end, and on the other end you drill and put the metal nut type insert that you drill a hole and it screws into the wood.
Okay, it's like the
Rockler and those companies all sell them. Yeah,
it's like
put a bolt on one side and a nut on the other side effectively is what you're doing with it.
Okay, that's good.
But
I never thought of
Rockler and
using.
Woodcraft and all those places would have those type of inserts.
Okay, Also, any sort of furniture store or table leg store or furniture manufacturer, they use those lag bolts that go into the table, and then
Yeah.
the threaded bolt goes into the leg, and then it threads up flush to your live edge or riverboard tables. Those are the hardware you're talking about, right?
Yeah, well, the bolt part looks like a screw thread on the outside and it has a regular thread on the inside. And
Yep.
you drill a hole, you're drilling an oversized hole and you're putting a screw insert into it. You use a screwdriver or a tool and flathead screwdriver and you screw it into the wood and that stays in the wood. It gives you the female thread and the other side is a bolt thread combination.
Okay.
Bolt and a screw thread combination. But
Okay,
Rockler
cool.
and Woodcraft and those places, those are the type of places that are going to have it. Highland
Okay.
Hardware and those stuff, stuff. Lowe's might have it, but I don't know. That's a little more advanced for them.
Yeah, it might be a little bit of a specialty item.
Yeah, it's a specialty hardware item, but and they're easy to put in. You just drill the hole and screw them in, both of them.
Yeah, because they're threaded on the outside too, so it catches the wood and it bolts and lags right.
Yeah,
into the wood.
it's threaded like a wood thread, wood screw. Just like a regular screw, it goes in wood on the outside. On the inside, it's threaded for, let's say, a 1/4 inch 20 bolt.
Yep. Okay. Yeah, that's a good idea. I'll have to try and see if I can get some of those too.
Ace Hardware, if there's an Ace Hardware around, they'll probably carry it as well.
Okay. Thanks for that. That's a great idea. I'll have to look further into those because I mean that bolt could be lagged right into that pilot hole where your Forstner bit goes, and then when you do your spindle, you could drill and put the other bolt in there, and then they would marry up together. So yeah, I'll have to make a couple with that that aspect too. Great idea. So now when I do the inside, I do the exact same thing. Now this won't take too long because we already saw me do it on the base. And then I'll get into the spindle. Oh, here, before I get ahead of myself, I want to double check, make sure these are tight. Now when I tighten these, I always tighten each hole a couple times just to make sure it's tight. If you have a perfect circle that marries up with your tenon, you won't have to tighten it too much. But you just want to make sure it's going to stay where it needs to be. Okay. This is running good. My finger is not bouncing and flopping all over the place, so I know it's running as true as it was between centers. If my finger was flopping all over the place, I would know that it's not mounted properly within my chuck. Okay. Now, just like we did before, enter, ride the bevel, cut across that surface, and make it slightly concave. And as I slow down as you reach the center, and I'm keeping mindful of that sharp edge and where my hand is, okay, because that will be very sharp. At this time, I can take my tool and I can soften that edge. Or sandpaper can soften that edge as well. I would then remove this. Oh, see? I've contacted here, but I haven't touched this side of the surface yet. So this is not true and flat and square yet, so I need one more pass. Oh, should slow down a little more there. I was a little too aggressive, but that's okay. It didn't blow out in the hole. Now to clean that up, you do one more pass. You could also scrape across the surface this way if that's your preferred method too. Okay. At that time, I would remove my tool rest, sand this surface slightly, soften that sharp edge because I do not want to cut my hand in any way. Now, when we remove the wood here, you don't necessarily have to remove the wood in the dome, but it is good practice for turning bowls, riding the bevel, entering the cut, opening your flute, cascading across the bottom. It's good practice for that. And also it's really just to remove some of the weight from the top end of your wig stand. If you have a top heavy wig stand that's heavier than your base, if someone bumps into the cabinet, it will start to rock and it could potentially fall off. So the base of your wig stand is chunkier or heavier or thicker than the top. So it's not top heavy and it's not tippy. Also, it will sit structurally sound on your table even if your table is bumped. And I find it's a little more aesthetically pleasing when the dome is smaller than the base. It just looks a little more right. But I mean, there's no rules. You can make your designs however elaborate you like. It's just the dome is 3.5-inch diameter to 5-inch diameter, and the base is anywhere from 6 to 5-inch diameter. I'll just double check this quick. So there I'm at 4.5. I'm at 4.5. Okay. Oh, sweet. Thanks, Martin. Martin's putting in the bolts he uses for some of the things he does. So that's great. Thanks, Martin. So here I'm just going to do the same thing. Start with your flute closed. Enter. It's not going to skate away on you. At that time, open your flute. Enter the cut. And move your body back towards the tool rest. So if you want to see my body position, I enter, closed, bring the tool back to my body, and I just move my body back and towards the tailstock. Stop before I go uphill. And that was, oh, here, sorry. That was this cut where I entered, rode the bevel, and I just moved my body back and towards the tool rest. And that gave me that arc, okay? That gives me the arc of the curve of the inside of that bowl. So now I'm going to match it and marry it up by coming the other way. And I leave about 1/8 of an inch wall at the top of that connection. Keep in mind how deep you want to go. We're making a wig stand top. We're not making a funnel. Okay. And then at that point, you can either scrape with your wing to clean up that surface. Just like so. We can also do a shear scrape here to clean up that surface. Whoop. See, I came up, I hit the curve, I have that at an angle. So it hit that curved surface. It wanted to skate away on me. So I was actually coming down to a point where I went to the bottom of that hill and I almost started to go back uphill. Okay. There we go. We blend the bottom. You can blend it with your tool or you can blend it with your scraper. Okay. Again, I'm cutting at center. My tool rest is above center. And my handle is in a trailing mode. And we just blend the bottom of that curve. Okay, and there we are. We have a blended bottom. Oh, one thing I forgot to do was taper this slightly. And I do that with my bowl gouge here. I start at the edge and I grind. I move the tool inwards to create a slight taper, just like so. That is much thicker than the other one I did, so I'm just going to make it a little thinner. Just feather and blend the two. Oh, here we are. And at that point, I would then take my sandpaper again. Just sand this surface slightly. I'm softening these corners so I don't get cut, but I want to keep this corner here pretty crisp. So I have a really nice tight connection to my spindle. Just keep in mind, don't touch it. Keep your fingers and skin behind the sandpaper, because if you kiss that, it will cut like a steak knife. Okay. Okay, that's pretty good. There. At that point, I take this out of the chuck. Now, the only switch we have to do is I got to take this off anyway. Oh, what grit am I using? That was 180. That was 180. I would usually go up to about 220, sand with the grain to remove any circular scratches caused by the centrifugal force of the lathe. But for the aspect of a demo, and we don't really want to watch me sand, I only did 180 start and stop, but it'll still give me a good finish. No tear out. Yep. Now I need to go back to my spigot jaw. Oh, wrong chuck key. Put this back on. Now I left 1/8 of an inch wall thickness that tapers down with the taper of the dome to probably a 1/4 inch. So at the bottommost point where this expands, at the bottom there, I have probably a 1/4 inch wall thickness, which is good because I want to have enough support to support that expansion pressure. If that was 1/8 of an inch all the way down, it would snap, especially if I was too aggressive and had a catch out here. Okay. Okay, we'll get that on there. Bring up my tail stock again for support. And I left that pinhole in there so I can center it right back up to where I was. We can see that here in this camera as well. Tighten that up. And that's pretty good. I mean, with the 2 points of contact, it's between centers, it's secure. I don't really necessarily have to expand that mortise to hold this. Well, actually, yeah, I do. Because I'm going to remove my tailstock to blend the top of that dome. The only thing you need to keep in mind is you only want to expand it so far. Now, how far do people say? If you hear a crack, that's too far. Okay. Now, first off, I can start with tailstock support. And the curve I have here on my dome, I really just want to blend that curve into the bottom of my tenon, just to give it a nice dome curve. Okay. Okay, and I can do that with my bow gouge. If I were to cut in this direction, I'm cutting uphill. If I cut this direction, I'm cutting downhill. But with my tailstock, I can't ride the bevel. So I need to do a peeling cut. And blend the dome, the curve of that dome. Okay, just like so. Now we have a nice curved dome shape to our dome. The only thing is now I need to remove this, but keep in mind with our live center, we have this pin that protrudes probably 1/8 of an inch in. We don't want a hole in the top of our wig stand. So from here, you can do a cutting action, light cuts. Because we're cutting uphill. Okay. And blend all this with a shearing cut. Or a scraping cut right now. I need to remove my tool rest for a shearing cut. There we go. Angle it up for that shearing angle. Come across. And there, we have our dome done. I still have a little pinhole here. There we go. But now remove my tool rest. And I would sand that. And here I'm starting with 180. Turn the speed down to about 300. I would be wearing a respirator. Just be a little muffled if I wore one through the demo. So I'll just hold my breath. There we go. It's pretty good. Here's the 220. Just a quick pass. Okay. And there we go. There's our finished dome. A little bit of tear out here, or just a little bit of fuzz or haze from that end grain. But to combat that, you can sand in reverse. And even if there is a little bit of tear out, the only person that's going to notice is another turner. The general public, the patients, I mean, anyone else, they'll love it no matter what. So now we're done our dome. Now we're on to the spindle. The spindle will be relatively quick. Then we can talk quickly about finish. And I just want to wiggle it off, because if I put that too off kilter, I'll have too much pressure on one sidewall than the other, and it could break or it could crack. Okay. So here's your base. Okay. Here is the dome. Nice piece of cherry will really pop when I get some finish on there. There we go. Now we're on to the spindle. Now when I do the spindle, I've found my centers just the same on both sides. I take an awl, mark my pinhole here. Now it's not crucial to do this on small items, but if you get into table legs, banister railings, across that length, it compounds. When you're trying to align your centers up, excuse me, it can be a bit of a balancing act. So by creating these little pinholes, it will seat itself perfectly within those pinholes, and it will stay centered over here while I line up my center over here. Okay. So if this was 3 foot long, it might be a balancing act. If I didn't make those pinholes, I would have to line that up, try and balance it here while I bring this up. It's just a lot easier to make those little pinholes, and it will find itself perfectly every time. And it will sit there while you tighten up your tailstock. Okay. There we are. Set up my tool rest. Always give the piece of wood a spin. It's not going to hit any corners. And for this, you could use a skew. You could use a spindle gouge. You could use a bowl gouge. You could use a roughing gouge. I'm going to use a roughing gouge. Now this is a spindle roughing gouge. It's not a bowl roughing gouge. A spindle roughing gouge is used specifically only on spindles. A bowl gouge is a bowl gouge is a bowl gouge. It's used on bowls. The reason being is this is form punched steel. This tang is 1/8 of an inch by 1/4 inch and probably goes in to the handle maybe 2 inches. And it all comes down to the grain orientation. Now, if I'm using this tool here, it's side grain. So if I get a catch, you can see those fibers just break out. If I were to use this on a bowl, where I have that wood grain changing orientation, where it's downhill, uphill, if this hit the end grain, it's not going to be forgiving. It's going to catch. It's going to be a very violent catch. And the size of this tang will not be able to withstand that pressure and that force. This will snap like a twig, and again, you might have an anti-tank round flying through the air. So on the contrary, your bowl gouge, this is drill rod steel. Your flute is cut out on a CNC. The drill rod tang is the same size as the drill rod, and this goes in probably 3 to 4 inches. So if I get a catch on end grain, okay, it might bury itself in there. It might give me a catch, but this won't break. It might bend, it won't break. You could wrap this off the side of a building. Again, it might bend, it won't break. So a bowl gouge is a bowl gouge on faceplate orientation. A spindle gouge is a spindle gouge for spindle gouge orientation. Oh, see, I'm turning in reverse. If you try and turn in reverse, you're not going to cut. Geez, why is that not cutting? Well, I need to go forward. So my tool rest again is below center. So as I use this tool, I'm riding at center. And when I use this tool, I lock it into my hip and I move my body back and forth. Anchor, ride the bevel, tilt the handle up to initiate the cut. And then I just move my body. Turn the speed up a little bit. Now I'm turning at 1400 RPM. Now the faster I go, the more scallops I'm going to create. The slower I go, the better finish I'm going to create. So just keep that in mind. When we're just rough shaping it, getting down to the shape, that's totally fine. We can slow down a bit and give us a nice finish once we're at that size we desire.
Kade, can you put your face shield down?
There, now we have our spindle perfectly round. If there are a couple tool marks, that's okay. We'll clean that up with the skew or your favorite tool of choice. May it be a spindle gouge.
Kade, can you put your face shield down?
Pardon?
Oh, there.
What?
Well, your helmet or your face shield was over top of what you were doing, that's all.
You were blocking the view from your overhead camera.
Oh, okay. Overhead, so right here. I'll have to stay here.
Just gotta stand back a ways.
There we
That's
are.
good. That's good.
Okay. Guess I got a big head. All right, so my vernier calipers, what I want to do here is I have drilled these holes to the same diameter, and that is 1 1/8 inches. Okay, so I want to set up my calipers to 1 1/8 inches, maybe a 1/16 more than 1 1/8 inches. There. That's a 1/16 over 1 1/8 inches. So this will be my measurement to create my tenons that will go into the spigot of my lid and my base. Okay? And when I measure that, I know I drilled these 3/4 of an inch and then I trued them up. So I have, I went a little below 3/4 inch, so I'm still at 3/4 inch here. And on this one, I'm closer to a 1/2 inch. So we'll make them both 1/2 inch, so I don't have to measure twice. Okay. So I take my ruler, I measure the size of what my tenon is going to be. So here's a 1/2 inch. Here's a 1/2 inch. Anything else can be full of glue. Okay. So right off the hop, that's where our tenons are going to be. Okay. And now we know the diameter of that outer portion on the lid is going to be 1 3/8 inches. Now we'll see if the other one is the same. Oh, wow. 1 3/8 inches. Cool. All right, so I don't have to do 2 different sizes here. Now, when I map out my design, there's many different designs you can look up, you can see online. You can get inspiration from banister railings, table legs. Also, if you type in wig stand spindles, there's a wide variety of different clubs, PDFs, shapes, and designs. So here's one I put together, which comes with a couple design opportunities, the directions on how to turn it, and then I have one here on my wall, which is all your sizes, dimensions, and whatnot. So you can find that online on my website, or if you would like a copy, I could also attach a PDF copy with the video, okay? So when I make my spindles, I like to make them uniform or somewhat symmetrical, whether it be coming together like a knee joint, whether it's a bead or coves, variety of different design elements you can use. If you want to hide the seam, you can hide the seam with a bead. A bead is a good way to hide seams of box seams, connection seams where a base or a lid meets a spindle, or even box seams. If you hide the seam within a bead, it's very inconspicuous and hard to spot. So you can do a bead. You can also do a straight taper where it flares from this dish into this taper and it follows that curve quite seamlessly. It all depends on what design elements you would like to use. So play with it, have fun, be creative, and
Kade,
yes.
John is commenting that your deep gauge is under your right foot. You've dropped it.
Pardon?
He
Oh,
said,
my depth gauge.
yeah,
Oh, yeah. Okay, thanks. Yeah, everything seems to have magnets. Okay, so I've mapped this out. Excuse me. Sometimes I do beads down here, but usually I have it flare into the same curve that comes off here. So I'm going to do that today. But when I make it uniform, I create my design within these 2 points. So I measure from one end to the other. Oh, that's exactly 10 inches. So 1/2 of that is 5. If I do a 1-inch bead there, okay. I could do a smaller bead here. And then a diamond bead out here. And then it will taper and flow into that taper which matches the taper of the tops and bottoms of my wig stand. Connect all the dots here. There we go. So now I have a perfectly symmetrical mapped out wig stand with the design elements I want. You can create whatever design element you like. So I'll have a larger bead on top of smaller beads, and then a V-style bead here, flared into the curve there. Okay. First thing we do is we figure out the diameter of our connections. And that is exactly why I measured this to a 1/16 above what that needs to be. I can always remove it later. You cannot always put it back, okay? Now, when I use this, you can use it one-handed, and if I use this, I use it one-handed, secured under my forearm, tucked up against my body for security and support as I make those cuts. Now I hold the calipers back here, and once I get to my desired diameter, it just falls over top. And I have a 1/16 of playroom, so I can still have a tight fit. Okay, the only thing you want to do with these, when you buy your calipers, they come with sharp corners. As you can see on these ones, I haven't softened them yet. Now, if I try and use that with those sharp corners, that is going to catch that wood. It will grab that wood, and now this caliper is flying through the air this way, okay? So really soften those edges, and this will run along the wood and fall in once you're at the diameter desired, okay? Start the cut, ride the bevel down. I hold my tool back here. And I got to my desired diameter and it falls right in. I'll do it again here. Well, that must have moved. Yeah, that moved on me as I was doing it. Try that again. There. Yeah, it moved on me. So the first one's a little smaller than needed, but that's okay. That'll be my glue catcher. Whoop. Now I caught that because I wanted to true up the end grain and come down. It just caught the end grain on that corner and skated a little bit on me. So a little more stable with two hands. And there we are. Now I'll do the same over here. My head's still out of the way.
Yep, it's good.
Okay. Now keep in mind, you want to use a spindle drive spur smaller than this diameter because we don't want to kiss our spur drive. It will do a number on our tools. Okay. And my final cut is slightly concave. Again, to catch any glue that squeezes out. Okay. Now the next diameter I'm concerned about is that outer diameter. There we are. So that is going to be my next cut. And I am a 1/16 above where I need to be. So I make that here. There we go. Okay. Now I know those are going to be my connections that connect to my outer diameter of that hole, and then the tenon is going to fit the inner diameter of my mortise. And now all I need to do is blend everything in between. Okay.
So Paul says that one way to put it back when you overturn the tenon too small is to take paper thin shavings of wood from a hand plane and glue them on.
Oh yeah, you could do that. Yeah. If you end up going a little too thin, that is a great idea. You could use some veneer. You could use some shavings. You could use a piece of paper, or just a lot of glue. Okay. So now I'm going to be using my skew. So whenever we use the skew, our tool rest is above center. So if we were to look at this as a clock face on this camera, if the bottom here was a clock face, right here would be 12 o'clock. So when I use this tool, I want to be cutting at 11 o'clock, okay? So that would be here, and 12 o'clock's right here. So depending on the diameter, we adjust our tool rest accordingly to be cutting in a planing cut at 11 o'clock, okay? The first cuts we need to do is we need to define where our beads are going to be. So we define those by making our entry cuts. And to make our entry cut, we use the toe rather than the heel, because the toe, we can see the cut being made over top of the heel. If we use the heel, we can't see over the toe, and you might wiggle it to try and see what you're doing, and then catch, skate away all the way down here, giving you that beautiful spiral design we all don't like. So when you enter in your V-cut or your entry cut, you want to be perfectly flat on this flat edge. And we lift, enter with the tip, lift the handle, and relieve out of the wood so the tool doesn't heat up too much. Okay? Again, I can define this. We'll define this one too. Okay? Now what you can do with a pencil, like I have here, is I marked my center line. You don't necessarily have to, but it's a good visual reference to see where to start, where to end, where to start, where to end, and what should be your highest side of that bead should be the very center. Okay? Now when we use a skew, first we want to remove some of that material by creating V-cuts into the piece to remove some of the material on either side of that entry cut, so we can come around that corner when we do our beads, okay? So when we do our V-cuts, we made our entry, stay in that position, 45 this way, just lift the handle. Again, back to your starting point, 45 this way, lift the handle. Okay, and I would do the same here. Okay, find this one here. Okay, and here we do the same. You always enter with the tip and ride that bevel downhill. Now when we use the skew, we always want to stay within that bottom third. So as I come downhill, riding that bevel, I'm riding the bevel here, but I have the tool slightly angled so I don't ride the bevel past that center point. Because if I do, it will catch that corner, skate away on you, giving you that beautiful spiral design we all love to hate. Okay. Also, what else will give you that spiral design is if I'm coming across in a planing cut. If I lift up off that edge, oh, it skated away on me this way. That is because as I was cutting, I was riding the bevel, came up off the bevel. This curve caught the curve of my skew, shooting me in that direction, or vice versa. Okay? Now, whenever I make this cut, I'm always cutting within that bottom third of that skew. Okay? So first off, we'll start with the beads. Ride the bevel, bring it back. We start to see some dust. Roll down and around that corner. Just like so. Again, ride, roll down and around that corner. So there's the start of our bead. Now again, I can do the same thing here. I want this bead to be not as high. Whoop. I overrolled too fast, came off that bevel. I'm going to remove these lower with a peeling cut because I want those lower than my big bead. Okay. These ones will be a V bead, so it's a straight taper on either side from that point. Okay. Okay, there's that one defined. Okay, this one defined. Now keep in mind, those are going to be sharp. Oh, here, keep my head out of the way. Now we want to match them up as closely as possible to one another. Okay. Now I need to clean up this bead, so my bottom beads will be pronounced. Okay. Again, I start here, initiate the cut, roll around that corner, and stop, closed. Start here, ride the bevel, pick up my cut, and closed. You want to match those curves on either side. There we go. Now blend that. There's our center bead. Now this small bead here that is quite tiny, just gonna clean up my V cuts. There and there. I'm gonna true up that surface with my parting tool so I have a flat surface to start at, so I don't get any skateaways. And now what I'm going to do is, a parting tool is a miniature skew. For me to maneuver this in there and come around that corner with the heel, it's possible, but it can be tricky at times to see it. So what you can do is you can use the toe or you can use a parting tool as a miniature skew. And I'll show you both. So here I'm using the toe, and I'm also using the toe because if I was over here and I entered with the heel, my toe is going to kiss the high side of that bead. But by entering and using the toe, and my heel is over here by the bead, you can see it's going to miss it as I create that cut. Okay. Just like so. The same over here. Now you can see this bead is a lot higher, and if I try to make that same position and come around, I'm actually going to kiss the top of that with the bottom of my heel. So I switch to my miniature skew, and I curl up and around that heel. Move my head over here into there for my miniature skew cut for my smaller bead. Okay, I can enter it here, come down and around. There we go. Miniature skew, enter with the tip, come down and around. There we go. Now I have my two beads defined here. One's a little off, one's higher than the other. So what I can do with my parting tool is I can blend the two by just going back and forth like this, rolling the tool around that corner just as if it was a skew. Make sure my head's out of the way. Just like so. There. Blend this a bit. Cascade up and around. Up and around. There we go. Now we have our miniature beads, our bigger bead, our V beads. Now we just need to blend the two. Now, if you have a high side or a low side that's sort of driving you batty that you just can't get with the tool because it's in a tight space, there we are. You can always blend it with sandpaper. Like, sandpaper is still a cutting tool. The only thing is we want good tool control presentation, so we minimize our sanding. But we can still use these to do minimal shaping. Blend any tool marks, blend any high sides. Oh yeah, I got a high side on that side that I'm gonna have to touch up with the tool. Now those V beads that are the highest part, you really need to keep in mind, watch out for those because those are what are gonna cut you. I have a spot on this side. I need to touch up quickly with the tool. There. Just a quick touch. There we go. There's our beads done. I soften these corners because I don't want anyone to cut themselves or grab it suddenly or catch it if it fell off the counter and cut themselves. So I soften that edge slightly. And I just sand down each side of those walls. Okay, that's pretty good. Now we have our uniform design that's symmetrical in the center. Okay, really good practice for your skew or your spindle gouge. Now all I need to do is blend this here and this here. So these 2 points, I can see this side's a little deeper than this side, but we fix that up in the end. I like doing stuff that's quite precise and symmetrical. So a lot of my precision or perfection, I guess you could say. Now I just want to remove some of this material to give me that taper. I'm going to switch that camera out of there. This is a planing cut. And I'm riding at 11 o'clock. And I'm cutting downhill because this is the high side. This is my low side. Cut that in half. I was getting a little too heavy and cutting uphill. Now I left a 16th here just in case I take a little too much there, but we want to make sure we ride the bevel, pick up the cut, take minimal cut there, and then heavier cut as we create that taper. And as I approach that wall of that bead, I slow down and I close that so the point is in contact with the point of connection. Okay? Now I just need to blend the other side. Now you can hold your skew however you like. It comes down to preference. In the beginning, when you learn your skew, you're going to have an overhand death grip to try and avoid those catches. As you get more comfortable, you might be playing pool with your skew. Okay? Enter. Now I want to enter on the face grain or the side grain. Well, the side grain, I don't want to enter in the end grain. Because if I enter in the end grain, it's very porous, it will catch your skew. So you see when I start here, I'm lying the tool flat on the side grain where the connection meets the bottom of my, meets the base or the top of my wig stand. So now this is much skinnier than this side, so I just need to match the two, but we knew that already because as I saw, this V was lower than this one. So I ride the bevel down here, pick up the cut, just to blend my connection. There. Now I need to do the same here. So I need to go a little deeper, right about there. Pick up my cut here. And just let the tool do the work. Let it cut. You want to slice the wood and cut the wood rather than plow through the wood or scrape the wood, because you will get a much nicer finish and far less sanding. clean up this edge, ride that bevel down to there. Now I just want to double check. I see here, what am I at? I'm at 1 inch. Here I'm at 1 1/8. 1 1/32. So I need to do a 30-second more. When I say precise, I wasn't joking. There. Now we have a symmetrical uniform spindle on either side. Symmetrical beads that match the two on either side of your larger beads. Symmetrical tapered spindles. And at this point, I would sand. Now, since I used the skew on all these cuts, I only need to start sanding at, well, really, you don't really need to sand. But if you're picky like me and you see a couple lines, you might insist on sanding. So here I started at 220 and I finish at 220. Here's my spindle. Remove your tool rest always when you're sanding. Okay. Got to remove this because it doesn't match this perfectly. Sand the sides. Sand up this wall. Now I already did this sanding, but I only did it with, I don't know, I was using the white paper, so maybe 180. Okay, now we have our spindle all done, all turned. Now we just need to see all those measurements I made.
Tom says the one on the right is 31/32 of an inch out.
Pardon? Sorry?
Tom says that the one on the right is 31/32 of an inch out.
Oh, okay. One more
30
pass. One more
31
pass.
out of 32 of an inch.
Oh, I don't know. It's pretty close. So here, I'm right here. 1 inch. Fits like a glove. 1 inch. Let's see down here. 1 3/8. Down here, oh, like a glove. 1 3/8. Yep. Here I have 1 1/16. Down here, oh, like a glove. 1 1/16. All right, so that should fit our spindle hole or the Forstner bit holes that we made. I hope my visor wasn't in the way when I did all those measurements, was it?
Nope,
Okay.
not totally.
Okay. Okay, so now we take this out. Here's our spindle. I'll switch to this camera that's not flickering and flopping. There we are. Now the moment of truth. Does it fit all the precise measurements we made? That one's a little thick. A little thick. So I have a little bit extra to remove on those sides. Only a 1/16. If I didn't, I would have the bottom come into a ledge. If you're happy with that, you can leave it that way. I moved my tool rest, so I need to go up above center here. I'll remove my mask there. There, back to this camera angle. No, we'll do this one here. Just blend it back slightly. There we go. Blend this edge back slightly. And just feather it in. There we go. Now where'd that sandpaper go? Remove your tool rest at all times when sanding. All right. Oh, yeah. Perfect.
Oh, let's see.
And perfect. Yeah. Here it is here. So now we can see we have a nice connection here. Oh, overhead. Here we are. We have a little bit of a lip, but that's okay. Not much at all. If I was really anal about it, all I needed to do was sand this down slightly.
And he is really anal about it. There you go.
And now we have a perfect seamless fit for where the base tapers in to the spindle. And on the top, the same thing on the top here. We have a good seamless connection. Exact same diameter. The only thing is, this was closer to a 1/2 inch depth. So this is a little longer than the recess. So I only see maybe a 1/16, but that's okay. All I need to do is go take this to the belt sander, a quick touch, and it'll be perfect. Now I'm done on the lathe. I can take my shield off, and now we can talk about the finish and assembly quickly, and then we're done. So when I stick these together, when I put them together, I use tight bond glue, and I put tight bond glue, actually here, I might as well sand that and show you. I'll do it all right at once here. So I'll just sand this on my belt sander slightly to remove some of that excess. I'm doing that on an 80 grit wheel, so it doesn't take long at all. Move a little bit more from the other one too. There we go. There we are. Here we are. Now they all sit flush. Okay, so what I do here is I take my Titebond glue and I take a toothpick. Usually I would take a toothpick, but I can't find a toothpick right now, so I'm going to use a 1/16 of an inch drill bit. Okay. I'm just going to grab this for the bottom of my, actually, no, I don't know where that went, so that's okay. I'll do it right on my bedway. So here's my clamps, very fancy high-tech clamps to hold this together while I glue it. Okay. I take my Titebond 3 or Titebond 2, Titebond 1, whatever type of glue you like to use. You could also use epoxy. Okay. I put a good coating of glue on the bottom of that recess. Okay. And I put a good coating of glue on the bottom of that recess. And then I take my 1/16 inch drill bit and I just wick some of that glue up those side walls. So that way it contacts the wood on the size of my tenon that is going to be fit within this spigot. Okay. I do the same here. There we go. And he gets on that lip, that's okay. Then from there, I wipe the excess glue on my pants. And I take my spindle. I put this one in first. You see, I have no squeeze out because that little trough caught all the excess glue. The only thing I want to do is I want to line up the grain so I have face grain, face grain, face grain. And then here I have side grain. So it looks like one solid piece. Okay? Now with this piece, I do the exact same. And I look for any sort of characteristics in the wood which might make it a feature. And I would line that up with, say, a feature on the base. So they complement one another. Okay? You want to put this on quickly before any glue squeezes out and drips down the sides. Okay? And then I take my really high-tech clamping systems. And I go here. I just need to move this to the edge. Start here. Hold it in place. Bring this up over top. Bring this into center. There we go. Pretty high-tech clamp. Then I do the exact same on this side. Start here, hold it in place. Bring it up over top. I just need to hold this down here. Oh, no, hold on. This guy here. Get that underneath at your center line. Now the lathe bedway will hold that in place as I bring this up over top. And then I just adjust my spindle so it's centered. I adjust my elastics so they're centered, so that way the centered elastics are pulling at the centered point of each spindle, so there's equal pressure on all four sides of that spindle. Now you can put more if you like, but I find 4 is usually enough. But just for Fun? We'll do one more. Okay, there we go. Now I would let that sit for 45 minutes to an hour before I decide to move this in any way. So I'm going to go to this camera, and now we can see our wig stand with our precise connections at the bottom and the top. We have a nice uniform symmetrical spindle which marries up at the top and the bottom seamlessly. And there's your wig stand. Now finishing options. We'll talk about finishing options quickly, and then we're done. We can have questions or open mic, have a discussion. So finishing. When you do finishing, these are going to be in contact with water, and potentially a lot of water until that water evaporates or dries. Now, I recommend using polyurethane, varathane. Avoid waxes, varnishes, shellacs, lacquers, and oils because they can react different ways to water. If you're going to use an oil, use a polymerized oil. So a polymerized antique oil, a polymerized tung oil, a polymerized Danish oil. It has to be a curing oil that has levelers and hardeners in it. Is it really an oil with all those levelers and hardeners in it? It's probably questionable to a plastic type finish when it becomes polymerized. So I would use either a, what's that one? You could use super glue finish or Parfix 3408. You could use tung oil, teak oil, walnut oil, Danish oil, tung oil, but they all have to be polymerized, not just pure. But your best finishes will be your polyurethanes and your varathanes. It's basically a plastic top finish. Or Rustin's plastic top coat would be another really good finish. You could do an epoxy finish, which would be borderline bulletproof, dent-proof. But again, with epoxy top coat finishes, it can be quite messy and sticky, and there's a bit of a learning curve. You'll get covered in epoxy first before you really get efficient at it. So my go-to is either a polymerized oil, but by far your best finish would be a poly or a varathane, or Parfix 3408, which is a super glue. Yeah, medical grade super glue. So any questions?